Hey everyone, welcome to another live coding. In this live coding, we're going to classify plant diseases or classifying images of plants and trying to figure out what disease they have. Um, as and we'll full disclosure. Usually, I go through a few different models and see what performs decently. Some technical issues before this one, so we'll be jumping into it a little bit more blind than normal, so it will be a bit more iterative, which will be fun. But before we start going into the model and all like that, let's start like usual and take a look at the data. So the data set you can find from Kaggle, as usual. Kaggle is a great place just to find data sets to do cool things with. And this is the data which we'll be using. I'll post a link for anyone who's interested in the channel. So you should see it now. I will post it in the description as well. And how this dataset looks like, it's actually pretty nice. We have clear here what the different classes are. So there's 5 different classes, not too many. Going all the way from healthy to some bacterial blight. Then we have the data itself, which is one huge CSV and then a bunch of images for it. And this is how most of our images look like. So this is what we can kind of expect. And they were also almost cropped to start with. They almost were all the same size, just a few here and there which weren't. So to the pre-processing which I did to get into PerceptiLabs was I just changed the Excel slightly so that it points into a folder rather than just having the raw digits in there. So that way we could place the CSV outside the folder, which is always a little bit more structured and nicer. And then I went through and made the images a little bit smaller so they would be easier to train on. So rather than 800 by 600, I think they were at start, we're going down to 533 by 400, something along those lines. Okay, but that's enough about the data. Let's jump into PerceptiLabs and start looking at building a model for it. Can skip the get started checklist. So let's create a model and we'll have the dataset already prepared here. I actually created 3 different CSV files. There's quite a lot of data in this one. It's 27,000 images. So we have one which is the full 27,000 images. Then we have one with about 7,000 and one with about 3,000. So we'll start with a smaller one and see how that one goes, and then maybe move up to a larger one. And as normal image classification, we will just have image input and category targets. We don't actually need to randomize the partition. As you saw in the CSV file, they were already nicely randomized. I'll throw it in there anyway. And we have some training settings which we'll worry about later. But let's jump into the actual modeling part first. So even with the smaller data size and the cropped images, they still take a while to load for some reason. I don't know if they have something in the files which makes them. You'll see as it goes a little bit slower than normal, but it works as it should still. We just need to wait a little bit longer. So this is the recommended model. We're going to try a pre-trained model to start with. So we'll scrap this one. And since the model is a little bit slower, or not model, sorry, since the data is a little bit larger to handle, we'll start with just a simple VGG model rather than jumping into a large ResNet model. And that way we can try the more lightweight models first and see how they perform before jumping into the larger beasts. So there will be a decent bit of loading before we get into the training part. As soon as we start training, things will go a bit quicker. We have the VGG. The good thing is we don't need to rerun these components, so once it's run, it's done. It'll be cached and it's we don't have to worry about it. And let's go with the first dense component. I've seen a few variations of number of neurons in it. I really like 128 with ReLU. It's been working well for me so far for other data sets. Another variation I've seen is 500 as well. If you want a bit more complex model. But let's start out with a simpler one and see how that goes. More things we're going to try after, depending on this one. We can try other backbones. So just different pre-trained models. We can try adding another layer. Many of these pre-trained actually have 3 dense layers after each other rather than just 2 when they're being trained as their original versions. These versions are cut down versions without including the top. So we can try adding another one if we for some reason think we don't have enough complexity in the model. And we would know this pretty quickly if we don't have enough complexity. That would mean we wouldn't really learn the training data. While on the other hand, if we do learn the training data really well, but not the validation data, then we're overfitting and we probably need some kind of regularization. Like dropout or just making the model smaller. It's on SoftMax on this last one, since we're doing a classification problem. So SoftMax is a distribution. It's or rather, it takes whatever output you have, and it makes sure it all sums up to 1. So in that way, it's really nice for classifying, especially classifying one-hot encoded classes, since you'll always be within the correct range. There we go. Let's connect it. As soon as this one's done loading, we can start training it. Funny thing is, I tried this on one other instance earlier, and it was running quite a lot faster. So I wonder if this is just this high latency instance I'm running on right now. There we go. And let's wait for the kernel to reconnect. There we go. So I do think it might be high latency. As you see, the kernel sometimes disconnects. Just giving it a second, it'll reconnect. Anyway, let's run on 5 epochs. 32 batch size seems good. Cross entropy loss, and let's start training. And I have one more cool thing to show, or one new cool thing to show in the statistics view. We updated the classification statistics a little bit, so it's a lot clearer to see what's going on with your model. While we're waiting for this to load, feel free to ask any questions about PerceptiLabs in general or machine learning, and I'll do my best to answer. Here we have the map. We'll see when it starts training as well. It's actually using full GPU on it, so it's not the machine that's slow. And also take a peek in the console and see if anything's happened, but nothing exciting there. Right, any second. There we go. Well, the good part is it has progressed in the background while it was loading. So since we do get the visualizations, we're caught up to where it should be. All right, so let's take a look at what we're actually looking at. So this is the slightly updated statistics view for classification. And we used to see accuracy during an epoch, so accuracy for each iteration, and then accuracy over all epochs. We changed that now, so it's just loss over all epochs instead, and accuracy over all epochs. The granular accuracy didn't seem super helpful, so we replaced it and just showed loss here as well, so you have more or less everything you need in one place. Let me change over to this one as well, so we can jump into gradients once it updates. At the bottom left, we still have prediction, which is ground truth, but over to the right, we have predictions for each class, and this is the new one. So how this one works is that during an epoch, while you make predictions, this one's going to show you what class you predicted for compared to the label. So for example, for class 3, or predictions which should all have been class 3, we have 6 predictions which are for class 0, 1 prediction or 7 predictions for class 1, 16 prediction for class 2, etc. So it's essentially a confusion matrix, and the cool thing with this is you can kind of see on the distribution how well it's performing. And now it caught up and started running faster. So for example, we can see that the majority of predictions for class 4 are actually 4s. Same for 3, same for 2, 1, and 0. And you can also this way keep track of if there are 2 classes which very easily get confused. So if 1 and 0 would get about equal predictions of both of them, that would mean it's easily mixing them up, mixing them together, and you could handle that by either changing your input data a little bit. You could pre-process it, maybe to make it easier, or you could try to make the model a bit more complex to account for this. Make sure the model is able to find the distinctions between the 2 different classes. Another thing it's great for, which I noticed pretty quickly, is you can see if there's any class imbalance. And I said before that I took about 3,000 samples out of those 2,700. Sorry, 27,000 samples. So 3,000 out of 27,000. And I just took the first 3,000. And looking at this, it turns out that the majority of those were out of class 3. Meaning that while we're training this, we have a pretty major class imbalance going on. It's almost 4 times as many of class 3 as there are of any other classes, which of course may make the training more difficult for the model. So one thing we could jump back and do immediately would be to either get a better CSV file, simply, with better distributed classes, or try the larger CSV file and see if that one has a better class balance. This is something we're looking to add into the data processing part as well. So already when you're creating a model, you're supposed to be able to see the class balance for, well, if you choose a classification issue problem, of course, you should be able to see the class balance in the CSV file. Other interesting things to look at, the gradients are looking decent. We have a spike here, but it's not too bad. It recovered after it. You really want to watch out for if this spike keeps growing. but just now, at one time, it should be fine. And for the accuracy, as usual with pre-trained models, it started out pretty high, and it kept going up. We haven't seen the third iteration, third epoch or later yet. So we'll see if those load at some point. The training should be more or less done now on the server side, so we're just waiting for it to update here on my end. Then the global is still the global loss. And the input will just show you the input images, which are nice to see, but probably doesn't help you too much in training model. There we got an update. And we can see the training accuracy keep increasing, which is perfect. But the validation, it's not decreasing, and the 62% is not horrible, but it's not increasing either. So this could be a case of the class imbalance, that it learns this class so much better. So for training, fair, it learns the rest well enough as well to increase its training accuracy. But for validation, it just fails on this one. It just classifies majority as this one. And that's something we can see after we have finished training, and we look at the confusion matrix. We can see how it classifies the different categories inside the test dataset. Right, it should very soon be done training. Here we go. I don't think we're going to wait for it to fetch the results. So we can go to the test. I'm a bit hesitant to running it, as we've seen with the statistics, how it's... I don't have the best connection to the server, so it keeps failing the requests. So I think we'll just stop the model for there and say their end results were over 90% on training and close to 70% on validation. Got a question. Is it possible to do something in NLP using the tool? Great question. Answer is yay. We'll very soon have, or very soon we'll during the summer add a text data type into the data wizard. And what that will do is that you can load your text data, it'll automatically pre-process it for you, and you can use it in the tool like any other data type. So that one's coming fairly soon. At the moment, you could, if you encoded your text data before you entered the tool, which is a little bit longer path, but still possible if you're willing to do it. But otherwise, keep a lookout for the newsletters and any updates in the forum or otherwise, and we should have text out in not too long. Right, I'm gonna call the live coding here for today. It's I hope you all enjoy it. We did get a decent model at the end, and I got to show off the statistics view, the new one. So I hope you like that. But thanks everyone for coming and watching, and have a great day and happy modeling. Take care, everyone.